Hello everybody. Welcome to my talk, Managing Human-in-the-Loop Systems Without Burning Out Your Engineers. More specifically today, I'll be talking about how at Pinterest we manage our machine learning operations, where we've incorporated as part of the machine learning lifecycle human. First of all, my name is Charles. Again, I'm a software engineer at Pinterest Toronto. So I have a quantitative background, degree in computer science as well as pure mathematics. But besides building software and working on the technical side of things, I love working with teams, designing systems, and thinking about different ways to make tools and processes more efficient. I was also the first full-time engineering hire internationally for Pinterest as part of the opening of the Toronto engineering office in 2020. So we've grown a ton since then, and we're still growing. We have over 70 people in engineering, product, and design, and we're also in the process of renovating a new office space that should be opening soon. So if y'all have a chance, come visit that when it's open. And now just to carry on with the rest of the talk, to give people a little bit more context, what are human-in-the-loop systems? Well, as part of the machine learning model lifecycle, it often involves human tasks. For example, humans labeling data, training models, validating the output of those machine learning models, and so forth. This happens in a bit of a continuous way where the feedback is given to improve the model over time. By the end of this talk, I'm hoping y'all have gained some insight into the type of work we do and the challenges we face at Pinterest when it comes to incorporating people and human tasks as part of our machine learning systems. And ultimately, think about ways to potentially improve or incorporate them in your own organizations as well. For today's agenda, I'm going to talk about things in kind of 3 chapters. First, I'll give everyone some context about Pinterest for those who aren't familiar with the product, as well as more specifically shopping at Pinterest. And then, of course, I'll talk a little bit about the team I work on and the work that we're doing. And then afterwards, I'm going to talk about the human-in-the-loop systems that we built, including how they work, what are some of the tasks and challenges that we face, and so forth. And finally, what we've built to address some of those challenges to make things a little bit more bearable for engineers, as well as how we close the loop as part of the machine learning lifecycle. So let's talk about shopping at Pinterest. Well, actually, to start, what is Pinterest, if you're not familiar with the product? So in short, Pinterest is a visual discovery engine for finding ideas like recipes, home and style inspirations, and more. So kind of how it works is people can create and discover pins, which can be images, videos, and products, and then save them to boards, and then share them with friends and others. A lot of it is related to life events, like collecting inspiration for a wedding, creating a board of interior designs for a new home, and so forth. So this is kind of some of the attributes on a pin, a title and link, description, and so forth. Now, specifically about shopping at Pinterest. So naturally, people not only come to Pinterest to get inspired and find products and save them to boards, but they also want to shop those products. So users, or pinners, as we call them, can explore the Shop tab to look at shopping products. They can also save them to shopping lists and discover related products. Now, we do this with what is called a product pin. So we turn a merchant's product catalog into product pins. Now, these are shoppable products where the pinner can visit the merchant's product page and buy the item in the pin. So on these pins, we display various shopping data, like the product's price, availability, and other rich information, like even whether free shipping is available for the product, how many ratings or reviews it has, and so forth. Now, shopping at Pinterest has been growing quite a bit. We've launched shopping features to 13 countries in 2021. There's a lot of exciting work in that area in the machine learning space as well. For example, things like visual matching in the images, product recommendations, information extraction as a few examples. Now, in order for pinners to trust the products that we display on Pinterest, and for us to provide them with a good experience, we must provide high quality shopping data. So that means the information I mentioned earlier, like the price and availability we display on the pins, must be accurate. More specifically, it means the price we display on the pins must match up with exactly what the pinners see when they go to the merchant's website and try to buy the product. Now, how do we get this data? So there's a couple large ways which we do this. The first way is the merchants provide us with this data. The merchants can upload and host a file on the web containing their product catalog, and then they can give us a link to it through our tools. We can pull the hosted data and ingest it and create the shopping product pins for them. So this sounds simple enough. However, this approach comes with some limitations. For example, since this product feed or catalog, in our case, is only ingested once per day, the information could be easily out of date, for example, if the prices change within the same day. Furthermore, the ingestion process could fail, such as if there's maybe some formatting issues in the file that the merchant provided to us, or other sorts of engineering bugs. Now, more recently, we've also provided a new way for merchants to provide their shopping data. Merchants can also provide their shopping data through our merchant API. So it's an API that they can call to add and update their product catalog. This is a little bit trickier, as it probably involves some infrastructure on the merchant side to be able to send requests and call our API. It might even mean some coordination with the merchant on our side, since they'll be needing to call our APIs in an online fashion. However, this does mean that the data updates can happen more frequently, and some of the issues like the data being out of date or stale won't happen as much. Now, another source where we can get the shopping data is directly in the HTML. For example, there's a lot of existing specifications or conventions or protocols on how metadata is stored on the web, stored inside the HTML. There's conventions like microdata or open graph, for example. So you'll see that in those meta tags there, they have some shopping metadata information, like the title, the currency, and the price. So what does this mean for us? Well, it means we can try to get the information we need directly from the product web page. So this is the area that my teammates and I work on. Our team has developed machine learning models trained on label data to try to extract the values from the HTML, which is provided as input. More generally, we work on extracting the shopping data from the HTML of the product pages using both rule-based extraction as well as machine learning models. So why do I want to do this? There's many advantages of extracting the shopping data this way. For one, it makes a lot of sense to try to determine the shopping data from the product page itself, as the product web page is where all the ground truth information is contained. So unlike the merchant-provided data or the embedded data in the HTML, which could be wrong, the data extracted from the rendered components of the HTML should largely match with what the pinners actually see when they go to try to buy the product on the merchant's website. It also means that on Pinterest side, we aren't relying on the merchants, some potentially very small ones, to try to send us their product catalog. However, there's still a lot of very interesting challenges getting the shopping data this way. To mention a few large ones, at Pinterest we have tens of thousands of merchants, each with their own unique domains and HTML layouts. So in order to extract this data from their websites, we must do it in a very scalable way. So this makes it quite a bit of an interesting machine learning problem, in my opinion. Furthermore, there's other challenges, like each domains will have their own rate limits, so we can't crawl the pages too often, despite the fact that the data on these pages might change over time. Or the pages might not render the content properly. For example, if JavaScript is not enabled when we crawl the web pages. And finally, when it comes to validation, just because we extracted something using our models or extractors doesn't mean it's necessarily correct. So when we try to show this information to pinners, we should guarantee that there's a high level of precision. So this means thinking about how do we validate or monitor our models in production, such that we have a high degree of confidence that what we extracted was correct without having the ground truth values in the first place to check. Now, I've introduced quite a bit of the context of the problem we've solved so far. So let's talk a lot more about the human-in-loop system we've built as part of the extraction development process. But first, I'm going to introduce the team or people for the human part of the human-in-the-loop. As part of our human-in-the-loop system, we partner with a really excellent team of 30-plus contractors based out of Manipur, India. We work very closely with them. We have regular meetings with them every week, and we share feedback and learnings and iterate on the HTML machine learning ops work that they do. So the Manipur team, as we call them, they work on writing the rules for our rule-based extraction, but also labeling the data and training our machine learning models or extractors. Now, more specifically, the Manipur team performs tasks like developing the rules for our rule-based extractors by writing XPath expressions. So if you're not familiar with XPath expressions can be used to query for values inside the HTML DOM. So for example, in the image here, we have some short XPath expressions querying for the text title and descriptions from a product web page's HTML. It can be very complex developing these XPath expressions. For example, it might involve sampling many example product pages for a domain and making sure all the edge cases are covered. And since these XPath rules are fairly static, they're very fragile and may not be robust to changes or small variations in the HTML and break. Now, to accelerate the extractor or machine learning model development process, and as our team moves to more machine learning approaches for extracting the shopping content, we needed a better way for the Manipur team to develop extractors. Hence, we built our own internal web application, which we call Pinpoint. Its labeling feature allows users to visually inspect and select the location on the web page to label the desired values for extraction. And we can train our extractors or machine learning models on this for extraction. So we use this to create sets of labels for training our machine learning models. And we can manage these models through the Pinpoint UI. Kick off training jobs from the Pinpoint tool as well. So compared to previously writing these complex XPath rules, this point-and-click labeling system is much simpler and takes far less time to develop an extractor model than manually inspecting the HTML, for example. So now we know how the training data is labeled by the Manipur team. We still need to evaluate the accuracy of our extractors or models. Now, this can be done by testing our trained extractors or models against test data, but what about once it's inside production? We don't have the ground truth values. So in order to monitor the quality of the data that we have in production and calculate metrics for tracking purposes, we compare the data that we're showing to pinners with the actual data on the website. And we do this by working with a vendor called Appen. So what Appen does is they provide us with a platform for crowdsourcing labeling work from people online. We developed a question form where we asked the raters about the data that we showed to pinners, along with the data on the website. And we show the raters the data on the website by using a screenshot of the website as a snapshot in time of what was on the website at the time the pinner saw the shopping data that we displayed. And how this is done is it's done through a scheduled data workflow where we send requests to Appin's API to launch these evaluation jobs automatically with thousands of sampled data from our production logging every week. And from the results of these human evaluation jobs on Appin, we calculate metrics on the results, such as the precision and the recall of our models in production. Now, in general, there's a lot of challenges when it comes to using crowdsourced workers. So notably, rater reliability is very important, which is why we have to qualify all the raters, we need to train all the raters, and iterate on the question form. So, for example, if the instructions are unclear, or the answers that the raters give will be inconsistent or unreliable, then our metrics won't be reflective of the ground truth. For example, in our case, initially some of the raters had trouble distinguishing between the sale price and the list price, with the list price being the non-discounted price on a lot of these shopping products. So what we had to do is we had to adjust the wording on this question form to make things more clear. Similarly, there were edge cases where we asked about whether a product had free shipping, but the product might have been a digital product. So the raters answered that there was no free shipping, even though it would have cost nothing to download the product after buying it. So after this human evaluation happens on the Appin platform, for the pins where the raters answered that the shopping data that we had at Pinterest was incorrect, we want to be able to triage and identify the root cause of these errors. This is very valuable information because it identifies examples where our extractors might not have been working properly. And we can incorporate this information in our Appin evaluation as well. For example, if we know there's a recurring issue, maybe we can skip asking that question with the known problems for a particular website or domain. One example of this is for Etsy.com, which is an e-commerce website for DIY type of products. They don't display the rating for their products, but rather they display the ratings of the shop on the platform. So in those cases, with these known type of scenarios, we might skip asking questions about the rating for a product on Etsy.com. Now, in the image here, we have this big Google spreadsheet. So in order to identify the root cause, we performed this analysis initially done through a spreadsheet manually. And this was very expensive in terms of costing us a lot of engineering time. It requires Pinterest engineers to go through the spreadsheets and look at what the problems are for the individual examples one at a time. It also requires human inspection and judgment to make a determination about the root cause of the issues. So there's some subjectivity in the process. And because the product web pages are potentially always changing, it might be difficult to reproduce an error afterwards if the nature of the bug or the error was time sensitive. Now, in order to improve this, we introduced automated triaging. So the high-level idea here is that we can program the triaging logic and apply it programmatically on the shopping data that was marked as incorrect by the raters from Appin. For example, if we know where the wrong data came from, then we can assign blame to that source of data being the root cause and take the corresponding actions for that data source to fix it. Also, similarly, if the value of the data was extracted at a time, at a certain time, and it was incorrect, but later on, the value on the website was now correct, we can say that maybe the problem was due to the data being stale. So based on comparing these values to the ground truth, we can programmatically figure out what the cause and triage the errors to see which errors maybe are recurring the most. So now we're going to be at the last chapter of this talk, which is closing the loop. So we've talked a lot about all the different tasks that involve humans as part of our managing our machine learning lifecycle, identifying errors, measuring accuracy, labeling the data, training the models, and so forth. But how do we link everything together so it's a full cycle process there? Now, to summarize the human tasks we talked about, first, we ask the Maniple team to do rule-based extractions. We also ask them to label data through pinpoint to train our machine learning models. And after we deploy these models, we'll want to monitor them and evaluate the data we're showing to pinners through the AppEm platform. And finally, with the incorrect results from the results of the AppEm evaluation, we want to triage the errors based on ground truth values provided by the Maniple team. In terms of these tasks, we want to be able to automate these tasks. So previously, what we've done is we will communicate with the Maniple team about these tasks over Slack, spreadsheets, Jira tickets. So how do we think about automating this feedback loop? So we're minimizing all the noise and the false positive while reducing the overhead of communicating these human tasks to the Maniple team. Now, in order to formalize the notion of all these tasks we're talking about, we introduced a task page on the Pinpoint web application. This is the same web application that we use for labeling data for our machine learning models. This page here will act as a bit of a work queue for the Maniple team. So what will happen now is the Maniple team can go to this page and they will know to label new domains or relabel data for existing domains to fix models or extractors. The tasks also come with a prioritization mechanism. For example, if there is more pinner engagement with a particular domain, we might want to assign it a higher priority. We can also set priority to domains manually if we wish, if we want to override that mechanism. Of course, we don't always want to manually create these tasks. So alongside our human evaluation, we can also create tasks automatically without human evaluation. For example, we can add automated monitoring, and we can automatically create tasks from our automated monitoring. This will send feedback back to the team to action on, to fix the errors without Pinterest engineers having to create the tasks or going through AppEm. So a couple of example tasks that we might automate is, for example, if there's a new domain detected in production that does not have a machine learning model or extractor associated with it, we can automatically create a task to label and train an extractor for that new domain. Similarly, if there's a coverage drop for an extractor or model in production for a domain that was previously working and it no longer works anymore, then likely what occurred was there was a change in the HTML or some other part of the system broke that caused the extractor to no longer work. In that case, we might create a task for the Maniple team to relabel the data or investigate and train a new extractor for that existing domain. So that kind of summarizes the work that's done on my team. I like to give thanks to Patrick, Michael, and Yuki, and the rest of the shopping content team. And please check out our career page as well. And also, I'm happy to take any questions about the talk as well.
Yep. Just opening the floor for questions. I have a question myself. For clarification, the training labels that you collected for the models, can you kind of repeat what the procedure was there?
Yeah, let me maybe go back and find the slide for that. Sorry, just to clarify your question, are you asking about the training or the labeling?
The labeling.
The labeling?
Yeah.
So in order to label the data for machine learning models, we created an in-house tool, and we call this tool Pinpoint. Basically, it's a bit of an interactive labeling system. So labelers, they can point and click inside the HTML pages here and highlight the location of the ground truth values that we want to extract. So for example, on this page here, we have a product page for Etsy.com. Inside the HTML inspector, we can see the price information there. So using this tool, we can label the location of the ground truth value that we want to extract from the HTML.
So it selects like the class for the object that they kind of clicked on, that kind of thing, like the class name in the HTML tag?
So yeah, so they would be able to visually click on the rendered page itself.
Yes.
Yeah.
But the actual data is like, what the model itself sees is like the HTML, and so that's what you're trying to select for.
Right.
Yeah.
So for the UI here is for ease of labeling.
Yeah.
But the models wouldn't be looking at the UI. They would be looking at the
yeah.
HTML content associated with it.
Okay. So for the models themselves, are they like language models? Are they like pre-trained? Like, what's the modeling approach in terms of?
Yeah, good question. So it's a little bit open-ended in the sense that this could be potentially agnostic of what type of model it is. For example, in this case, we get the XPath for the location of the label data, right? So it could be something very simple, like a rule-based solution, where we take the XPath of the label data directly and just use that as an extractor. Or maybe we learn something more sophisticated. For example, learning some heuristics or rules based on the elements inside the HTML. So there's various semantics associated with names of tags or classes or attributes inside the HTML, and we can learn patterns on that. And of course, if you want to go, even more sophisticated, maybe some sort of deep learning model where there's, a lot more abstract type of inputs or features and things like that. Mm-hmm.
I guess with your approach, like, did you test like generalization to unseen kind of tags that's like unseen data? Like, how do the models generalize based on kind of your training?
Yeah, good question. So before we deploy the models, we'll go through like a model evaluation phase. But like I mentioned earlier, once the models are in production, we need to make sure that they're still working. But it's a challenge because we don't know what the ground truth values are. It's a bit of a chicken or egg problem, right? How do you know your extractors work unless you already knew the ground truth values? But if you knew the ground truth values, you wouldn't need your extractors in the first place.
Like if it was just like leave out data, like validation, or let's say like a schema that the model wouldn't have seen before, like on those sites, like you could say, like it's already labeled, so you can just kind of test it.
Yeah, exactly. So what we can do is we can use test data where we already know the values and then compare them manually afterwards. Okay. Or once the models are in production, we can monitor them and send the results that we log, for example, to the Appen platform and have the crowdsourced workers evaluate the quality of our data. Okay. And if they find any mistakes there, we kind of close the loop there by creating these tasks for the Maniple team to retrain our models and fix the problems that we've identified in production.
I see. I guess so. There's no testing with like language models, because like with language models you have pre-training and it can generalize quite well and use like semantics and context, some of the things that you kind of mentioned, in order to extract, let's say, like relevant entities. Has that ever been used in practice, or any thought to that, or?
Yeah, I guess, again, sort of the human ML ops work here is kind of independent of the underlying machine learning model, methodology. So, for our approaches, we started off with more simple rule-based approaches and then did more sort of classical machine learning approaches. So the large language models and stuff, I think there's potential for that in the future as well. But yeah, it would kind of be agnostic or independent of the ML ops side of things. Mm-hmm.
Okay, thank you.
Thank you so much for a great presentation. Mm-hmm. My name is Matthew. I work at a company called Raptor Maps. We have a very similar human-in-the-loop setup for labeling and validation. Probably one of my biggest challenges has been the training, and I'm curious what are some of your best practices for training. Training of your work of the Maniple team for labeling and of the crowdsourced tool for validation. Mm-hmm.
So just to clarify, when you say training in this case, you're referring to training the humans. As opposed
exactly.
to
Yeah,
okay.
one of my biggest time sinks has been training our workforce to label data and validate it, and it's been just a pretty big time sink, and it can be hard, especially for very like nuanced labeling problems that aren't just object detection. It can be really difficult. To train them, and it's been one of my biggest challenges. So
right, that's a great question. So I think for our team, we kind of work with two crowds of humans here. One is the Maniple team, and they're kind of our in-house contractors. So we're able to get kind of a very low level with them in terms of the work that we want them to do. We have weekly meetings with them. There are in our Slack channel, so we can kind of have that in-depth training and communication back and forth if we find that something is not what we expected in terms of labeling and things like that. So I think that's one thing, and also the tooling helps quite a bit, right? So for example, for the role-based extractions, the Maniple team may have had to develop these complex XPath expressions. So relatively speaking, that'll require some technical background, right? You have to at least know how the HTML works, how to write these query expressions, right? But we can simplify it for them by building our labeling tool, for example, where it's very sort of low tech heavy. You just have to point and click to know how to label the data there. So I would say maybe one way we've kind of tackled it is having that sort of close iterative working relationship, because it's an in-house kind of contracting team we're working with, but also making the tooling simpler so that maybe the training cost isn't so high because the tooling is so simple, right? Now the second group of humans that we work with are the crowdsourced workers. So those aren't contractors. Those workers come from our vendor Appen. And the training there is a lot more tricky because they might misunderstand the intent. So some of the best practices we followed is we provide them with a training guide, for example. We qualify the raters. So if any of the raters, they don't perform to a certain standard, we disqualify them from participating in the rating jobs, as well as creating golden set data to qualify the raters on. So we have our in-house shopping specialists as well, or market specialists. For example, if we need to launch a new measurement to a new market, they might go through and create a data set just for that market when we do internationalization. So the raters in that market will be able to understand the instructions that we're giving them, maybe even translate it to their native language. But yeah, that's always a bit of a challenge, but it'll take a few iterations to get right. Yeah.
Thank you.
Mm-hmm.
Thanks for the talk. Do you evaluate the labels from the Maniple team with some like data-driven methods, like some agreement scores or like other methods, or do you just trust them with the labels they produce?
Sorry, can you repeat the question a little bit? I didn't quite catch.
Yeah, do you evaluate the Maniple team labels with some data-driven methods, like some agreement scores they can compute after they label whatever on the pinpoint thing? Or do you just trust whatever they label?
Oh, I see. Yeah, for the most part, there are some assumptions built in there are some assumptions in the sense that if your labelers aren't reliable, then your models aren't going to work in the first place. So as part of our tooling, for example, we have ways to try to make it so it's simpler for them so that they don't label the wrong thing, for example. And we also do things like model evaluation, where we compare some validation metrics against the test set data or the training set data to see if it passes a certain threshold. So, for example, if the labeling values are inconsistent or they're unreliable, then the score for the evaluation for the models might be very low, and we might not want to deploy that into production. So there are some safeguards in place. And of course, if we notice these things, we can always communicate it to the Maniple team, and they'll go and fix it as well.
Okay, good. And for example, like, do you ask maybe multiple people from the Maniple team to label the same sets of data just to compare things together, or like do you just have like one person label like uniquely one set of data?
Yeah, that's a great question. I think on their end of things, how they manage their work is typically, I believe, one person labels a set of all the labels within the same website or domain. But also, we make it very easy for them to reuse labels across different pages. So a lot of the times, the HTML doesn't actually vary for a particular website. So what you can actually do is you can reuse the XPath expressions you've used for labeling for one page to another.
Okay, thank you.
Hi, Charles. Thanks so much. That was great. Just had a quick question. Can you give us an idea of the sort of timeline this took in terms of sort of building it out and seeing it into maturity, and then as well, how many people were working? I don't mean the Maniple team per se, but sort of the folks in your office that were tasked with this. What did that team size look like? Thanks.
Yeah, for sure. So like I mentioned at the beginning of the presentation, I joined Pinterest as the first international full-time engineer as part of Pinterest's expansion into Canada. So our engineering office in Toronto opened in 2020. So I've been at Pinterest for a little bit over a year and a half now, working on the system. So I would say, yeah, all this kind of took maybe a little bit more than a year to build out to the level that's in this presentation right now. And initially, it was just me and Patrick, my manager, on the team. But I think we're about maybe like 8 or 9 people now. So we're always kind of hiring in Toronto, and the teams are getting very large. So yeah, I would say the team size is about that right now. And then it took about a year to get to this point. When I joined, we didn't have the labeling tool at all. We didn't have the automated monitoring or the task creation. So that was all built from scratch and added later on after I've joined. Mm-hmm. Well, thank you everybody for attending my talk. Yeah.